Assalamualaikum and good morning to our beloved lecturer Puan binti Abu Bakar and our friends. Before we start the discussion, I would like to introduce myself first. My name is Nur Sarah Liana binti Nur Azizi and my matrix number is 01DKA21F1084. The first one, I'm going to discuss with you the introduction of setting out. Construction of surveying known as layout or setting out is to stake out reference points and markers that will guide the construction of new structures such as roads or buildings. Construction surveying is generally performing the following tasks. The first one, survey existing condition of the future work site, including topography, existing buildings and infrastructure, and even including underground infrastructure whenever possible. For examples, measuring invert, elevations, and diameter of sewer at manholes. The second one is stake out reference points and markers that will guide the construction of new structures. The third one is verify the location of structures during construction. And the last one, a survey conduct at the end of the construction project to verify the work authorized was complete to the specifications set on plans. Next, I'm going to share with you the theory of setting out. Setting out is the translation of construction plans into physical point on the ground that can be used as a basic for the actual construction. Almost any roadway, building, or other man-made improvement probably had some amount of the construction surveying involved. Construction surveying provides not only the horizontal location of new structure, but also vertical information required to ensure the surface drain or pipe flow as required. The layout or stake-out survey consists of locating and marking horizontal and vertical control points to guide construction crews and gilby lines and grade as needed to establish additional control points and to re-establish disturbed stakes. The setting out surveying will start with calculates information from drawing to ensure that the first one, building can be positioned correctly along with all the necessary structure components within it. The second one is all structure components are built to correct level, and third one is line or level for structures, road, drainage and earthworks are provided. Next, when the site layout design has been established, all this information is accurately transferred onto site. Using the latest survey instrument, the setting points can set up on site as required, based to the design drawings and design coordinates. In addition, the setting out will also include the check surveys at various stages throughout the construction process, which can involve the independent checking of points set out by others where quality monitoring is required. The objective of this report is to carry out accurate setting out, next to carry out all the necessary calculations to establish the setting out points. Third one is work as a team in order to execute a large-scale surveying work, and last one is produce and present an engineering report on an engineering survey work.
Okay, Bismillahirrahmanirrahim. My name is Alif Amir Adli bin Isham. My matric number is 01DKA21F1094. So I'm here to present to all of you about the equipment that we use in setting out. So for the first equipment is total station. Total station is an instrument that automatically measure distance and angles. Total station also has a memory chip that allow data measuring angle and distance to be saved for later download and computational processing. So for the next equipment is prism. Prism is the target total station in determining the angle and distance. So next is pole and mini prism. Pole is to measure the elevation of an existing ground or grade by using a site level, which is important if you want to get accurate result. Mini prism it can increase accuracy rate and reduce error. So for the next equipment is tripod. Tripod is a device used to support any of a number of surveying instrument such as theodolite, total station and levels or transit. Okay, so next is tape. It is used to measure the distance between 2 points. And for the last one, we have wooden pegs. It is used as a survey station marker. So next, I will tell you about the fieldwork procedure. But let me tell about the preparation and planning first. So we prepare and planning that the setting out of the building corner performs according to the position taken from a topographic and detailed plans. Number 2 is position of the proposed building identified by RIS, the site according to the site plans. Number 3 is the nearest traverse station to be used, identified as setting out reference point. Number 4 is corner of the building to be established on the ground, and the lastly is data of setting out to be calculated. Okay, let's go with the field procedure. So the first step is the center line of the longest outer wall of the building is marked on the ground by stretching a string between peg embedded in the pillar. This line serves as a reference line for making the center line of the buildings. Number 2 is project the pegs above the ground level and drive a distance out 2 meters from the edge of the excavation. Number 3 is stretcher a string jointing the corresponding pegs of the two ends of the line. Number 4 is the boundary of the trench to be excavated can be marked on the ground with dry lime powder. Number 5 is the center line of the other wall which are perpendicular to the long wall. The mark by setting out the right angle can be set out by forming a triangle with 3, 4 and 5 unit line side. Okay, so next, number 6, the diagonal should be checked for ensuring the right angle for all the corner. Number 7 is the top of pillar is plastered and it is set at the same level. Number 8 is take out the embedded in the pillar and the corresponding line are marked on the wet plaster, serve as by pressuring the stretch string on a surface by a trowel. Number 9 is the outside line of the foundation trench is marked similarly. Number 10 is before starting excavation, the string are stretched between the outside line of the foundation trench marked over the pillar top and the cutting line are marked on the ground by lime powder. And for the last one is establish each room measurement by nail and also mark out the block wide as well as the excavation or working space from each side, of which the width of the block is multiplied times to give the total excavation wide. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syafiqah Zahira binti Banasir. My meter number is 01DK21F106. I would like to continue our presentation to present about data collection. So with the value given from the school dial, we can know value of radius level, channels, inward level and more. From the given, we can know value of radius level of A 94.400, inward level of A 92.685, B 94.305 and the channel is 20 meter, C 93.862 with the channel given is 40 meter, D 93.685 and the channel is 60 meter, and lastly E 93.615 with the channel given is 80 meter, and also BN1 and 2 is 95.00 meter. Next, I would like to present about analysis and data calculation. With the value has given, we can know distance from A to E is 80 meter. Gradient is 1:120. Traveler level is 2.5 meter, and inward level A is 92.685 meter. So first, we must to find the radius levels of the side rays at A to E. So the formula is radius level of the side ray equal inward level plus length of traveler level. For example, radius level of the side ray A equal 92.685 plus 2.5 and the answer is 95.185 meter. So you guys can do this formula to find radius level of the side ray at B, C, D and E. Next, we must find the head of side rays above ground levels at A to E. So the formula is the head of side rays equal radius level of the side ray minus radius level. For example, head of side ray A equal 95.185 minus 94.400 and the answer is 0.785 meter. Besides that, we also important to know invert level at every point. So the formula is invert level S minus invert level Y per distance equal value of gradient. For example, invert level A is 92.685 minus invert level B per 20 equal 1 per 120. So we can get the value of invert level B is 92.518 meter. So you can continue the calculation to find another value. Next, I would like to find value at point C. So first, we must find invert level at C. Invert level A minus invert level C per 40 equal 1 per 120. So the value of invert level C is 92.352 meter. And then we must find reduced level of the side rail C, which is 92.342 plus 2.5, and the answer is 94.852 meter. And lastly, we can find the head of side rail C, which is 94.852 minus 93.892, and the answer is 0.99 meter. And lastly, you can use this formula to find the value at D and E. So that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nasrul bin Muhammad Khairi. My metric number is 01DKA21F1073. Okay, and then I will explain about effectiveness of team and comment and conclusion. Okay, first, effectiveness of team. We all contributed ideas to the team on how effective the discussion was. We achieved good job outcome after working together to complete this task. We assign work to each member in an appropriate way. Hence, we are also willing to help each other. Each of us communicates on a regular basis, so the expectations are clear. By mixing and acknowledging personality, types and skill set instead of trying to force people into a role where they don't excel, we have created a more complete and stronger team. Finally, our task has been completed. For the comment and conclusion, as a conclusion, we discovered that setting out is important in civil engineering project. Setting out is an add-on to the tachometry survey. Since we can find any free area by looking at the tachometry plan with this method. Furthermore, if we require that space but there are numerous trees in the area, we can arrange to remove it from the tachometry plan. As a result, we can determine which location is good for any construction. We can determine the point and area for the proposed structure after the setting out is completed. The setting out point is in a vast area that includes the traversing area. After all of the work is completed, we will be able to learn the setting out process and how to obtain the bearing and distance as specified in the objective, which we will be able to apply in future work. This method has been used by all contractors around the world. And that's all from our group presentation, and thank you for listening.